Now, to determine the amount of energy stored within the magnetic field of an inductor, we have to recall our expression for power. Power is equal to our voltage times our current. Now, if we substitute in our expression for our voltage potential for an inductor, our power is equal to our inductance times the time rate of change of our current times our current. Now, the energy stored within our inductor is the time integral of power, such that the energy within our inductor, E sub I, is equal to the integral from T naught to T of P of tau d tau. Now, if we substitute in our expression for power, our energy stored within our inductor is equal to our inductance, since that is a physical material property that does not vary with respect to time, times the integral of T naught to T of di of tau d tau, I of tau, integrated with respect to d tau. We see our d taus cancel out, and we're integrating I of tau with respect to di of tau. Thus, the energy stored within our inductor is our inductance per 2, I squared t minus I squared of t naught. If we assume that our initial current within our inductor is 0 at time t naught, our energy stored within our inductor is our inductance per 2 times our current squared. Now, to illustrate this, let's look at example 2. Say we want to find the power and energy stored in a 1/10 Henry inductor given that our current is equal to 20t e to the minus 2t amps, and our voltage potential existing across the device is 2 e to the minus 2t times the quantity 1 minus 2t volts for all time greater than or equal to 0, assuming that our initial current is equal to 0 for all time less than t. Now, to begin, we'd look at our power equation. Our power is our voltage times our current. Our voltage is 2e to the minus 2t times 1 minus 2t, quantity times 20t e to the minus 2t. Thus, our power is equal to 40t e to the minus 4t times the quantity 1 minus 2t. And the energy stored within our inductor, E sub I, is equal to our inductance per 2 times our current squared. Our inductance is 1/10 of a Henry, divide that by 2, and our current is 20t e to the minus 2t squared. Thus, the energy stored within our inductor is simply 20t squared e to the minus 4t joules.